Okay, yes. So good evening, everyone. Good evening once again. Right, we will continue with elasticity. है ना? So okay, let's start with the revision recall test. Okay, if a cylinder is compressed, है ना? If a cylinder is compressed under the action of applied force, the restoring force per unit area will be known as. Tell me. Theory. Very easy. Very easy. Everyone. Very easy. Very good, Smarnika. Very good, Pragna. Very good, Suktika. Very good. Right? Easy है कि नहीं? Correct. Right. Okay. First one, easy. Correct. Compressive stress. Very good. है ना? Next, second one. If the value of ultimate tensile stress is very close to fracture, think about it. Right? If the value of ultimate tensile stress is very close to fracture point, very close to fracture point, then the material is called as, tell me.
Brittle.
Okay. Right? है ना? Okay, chalo. Mostly you said brittle. Okay, very good. Third, if a larger force is required to produce a small change in length, right? If a larger force is required, force large, right? For small change in length rod. So I'll just write the formula. Right? है ना? Tell me. Correct, Prashasti. Very good. है ना? Right? Largest force is required for small change in length of material B than A. Common sense है ना? मतलब नहीं भी फॉर्मूला पता हो तो तब भी तुम common sense सोच के बता सकते थे. Right? Right, everyone? Tell me, what would be the answer? Only Prashasti gave the answer till now. Tell me, if force is more, right? Same length, same area, right? Right? Same length, same area. Tell me. B, correct. Okay. Okay. ठीक है. Fourth, fifth. In a stress strain curve, the material breaks after ध्रुव सोचो एक बार. Fourth का Sampada, think about it. This is proportional limit, right? This is elastic limit. This is plastic limit. तो point से याद रखो ना. Very good, प्रीति, कि कहाँ पे क्या क्या होता है. If you remember, right? ऐसे, फिर थोड़ा सा ऐसे, फिर पूरा ऐसे. ये पॉइंट होता है, फिर ये पॉइंट होता है, फिर ये पॉइंट होता है ना? Okay, चलो. Fifth one. In a stress strain curve, the object is not elastic. Okay, in proportional limit beyond this point, beyond yield point, True or false? True or false? Tell me. Beyond yield point. Yaad hai? Okay, let us see the answer. It is, yes, it is false. है ना? This was plastic limit. This is correct. This is correct. This is correct. ठीक है? Got it? समझ में आ गया? So this was your revision, है ना? Okay. So I hope all of us have covered this, है ना? Right? Searle's experiment was just an experiment. Okay. So, right, just give me a minute, guys. Apologies. Okay. Now, before starting today's concept, okay, I would like to ask you basic thing. How many of you remember equivalent resistance? Tell me. In series and parallel, raise your hand. Everyone? Yes or no? Right, everyone? Yes or no? So before talking about any other thing, let us talk about rods or springs, right? Better. Let's talk about springs. Springs, okay. Now we know that when you talk about spring, okay, everyone, step by step, right? Spring have spring force as minus kx. Yes or no? That's your restoring force. Yes or no? That in the restoring force, when you talk about restoring force in spring, it is minus kx. Yes or no? That spring force is always opposing. Right. Okay. Okay. Very good. So when you talk about the spring force, or if you talk about any rod or any rubber, all of them will, tell me, all of them will have same concepts. Yes or no? Tell me. Both of them, either you talk about spring or you talk about rubber or any elastic substance, both will have same kind of restoring force, which will be proportional to their change in length. Yes or no? Tell me. Yes or no? Right? Okay. Yes. Very good. Right. Okay. Now, if I'm talking about spring, we know that change in length, delta L, right? Delta L is given by what? I will consider your normal elastic body like a rubber, like a rod. Okay. So it is F into L by A into Y. Yes or no? Right? Basic formula. Basic formula. Okay. Right. Okay. Now think about it. Before talking about anything else, I will just ask you this. Okay. Suppose I'm having a rod, right? I'm just talking about a rod. Yeah. First, let's talk about a rod. Okay. I'm a rod. Okay. Right? This is a rod. Yeah. Or rod. Let's talk about spring first. Yeah. Okay. Right? So it will have a force mg in downward direction, spring force in upward direction. Yes or no? Any issues on that? No, this is very clear. This is very clear, right? I'm just trying to understand what is happening. Right? Without talking about the topic. Chalo, okay. Now think about it. Think about it. So this spring have a spring constant K1. Okay? Spring constant K1. Right? So I guess if we know these things, we can calculate X. Yes or no? We can easily calculate X without even worrying about these stress strain relationship. We can calculate. Yes or no? Hi Anna. Can we do that? Right? Yes, sir. Obviously, at equilibrium, we know that F is equal to mg, right? So K1x is equal to mg. So X is equal to what? Mg by K. This is something that we already know. Yes or no? Tell me. Hi Anna. At equilibrium. Okay. Anyone have any doubt in this? Raise your hand. Anyone have any doubt in this? Step by step. Step by step. No, right? No, no. Okay. But now my question is, what if you will pull it further? Suppose you pull it further by some force F. What will happen? Think about it. क्या लग रहा है? What will happen? Everyone, think about it. What will happen? Step by step, everyone think क्या होगा? Length will increase, yes or no? Right? है ना? Common sense है, right? That the length of spring, the elongation will increase. If I ask you, okay, ठीक है, by how much now? Now by how much? अब कैसे पता चलेगा? By how much it will increase? Tell me, by how much it will increase? Now, how you will know that by how much length will increase? नहीं, बट हम कैलकुलेट नहीं कर रहे हैं ना ध्रुव, हम एक्चुअली थोड़े ना लेंथ को मेजर कर रहे हैं, राइट? वी हैव टू फाइंड ना, वी हैव टू फाइंड yes or no. This is your normal elongation. I have to find change in elongation, yes or no, right? Length increase minus initial length संपदा, but length increased ही तो चाहिए हमें पहले, yes or no? Think about it. We know, like whatever I'm asking is very intuitive. I'm not talking about कि हाँ मैंने कुछ बोल दिया तुम लोग मान लिया, है ना? Right? स्ट्रिंग नो नो मासलेस, मासलेस हर चीज मासलेस मान रहे हैं, लिख दो, मास वाला कॉन्सेप्ट ला ही नहीं रहे, ठीक है? टोटल मासलेस वाला चीज है, जस्ट एक फोर्स के कारण क्या हुआ, मैंने एक्सटेंड किया, तो ऑब्वियसली बिकॉज ऑफ दैट इट विल एक्सटेंड, राइट? नॉर्मली दिख रहा है हमको, है ना? दैट इज ऑब्वियस, यस और नो? टेल मी यस और नो, दिस इज ऑब्वियस, राइट? ओके, है ना? ओके, राइट. So this again food for thought. What will happen? How to find it? But let us compare this. Wait. Yes, Nick, correct. है ना? Correct. This is easy. Na? This is easy, right? All of you can easily calculate. We know that. Now, if you apply, sorry, this is minus kx. This is f dash. I'll say, है ना? So total f dash will be what? Mg plus f dash. That should be equal to what? Tell me. K1 into new x, which is x2, yes or no? This is x1, yes or no? Right? है ना? है कि नहीं? So x2 will be what? x2 will be mg plus f dash by k1, yes or no? Simple ना? हाँ है ना? रेशमा समझ में आ रहा है? Sorry, रेशमा is not joined. रेशमा, I guess रेशमा has not joined yet. रेणुका, सुक्तिका, शांति, सिंचना, है ना? राइट? है ना? After f dash is applied, okay, right? So I guess all of us can calculate delta x, है ना? चेंज निकल जाएगा ना? Yes or no? Right? So what is delta x? Tell me. Delta x, as you guys said, x2 minus x1, x2 minus x1, yes or no? So if you do this x2 minus x1, what will happen? Everyone calculate this minus this, what will happen? Tell me. It would be what? F dash by k1 only, yes or no? हाँ या ना? राइट? mg वाला कंपोनेंट कट जाएगा, yes or no? समझ में आया सबको? राइट? Anyone have any issue with this? Raise your hand. Anyone have any issue in this? Raise your hand. Okay, no issues na? This is basics. I'm not talking about any concept of stress and strain now. This is just some one basic concept of NLM, है ना? Okay, now I will use this. This was a prerequisite, है ना? This was your prerequisite. Okay, now we know that when we talk about any elastic body, okay, now I'm talking about any elastic body. Okay, any elastic body. Now I'll consider this as massless only, okay, right? No integration, nothing is required. Okay, right? Normal. Some mass is there, normal. Okay, right? I'm not talking about what is tension and all those things. So for this body, what is delta L? If force is applied, suppose if force F is applied, here, right? what is change in length? So I know that F by A is equal to, tell me, is equal to Y delta L by L. Yes or no? Correct. Very good. So if I have to rearrange this, can I say, sir, F is equal to, tell me, delta L into Y into A by L? Yes or no? Yes or no? Right? So if you see this, can I say, sir, it is what? Sir, this whole thing is a constant for this object, right? This rod, this whole thing, right, is fixed, है ना? Right? Or I'll just write down this. F is equal to YA by L into delta L. Delta L. Delta L is nothing but, tell me, if you compare this, can I compare this with F is equal to minus kx? Or just take the magnitude. I'm just talking about the magnitude, right? Because delta x, delta L, in case of increasing, in case of decreasing, it will change, right? Sign will change. So I'll just take the magnitude. If I have to compare with this, don't think this and this are comparable? Yes or no? Yes or no? Think about it. हाँ या ना? दोनों सेम टाइप का फोर्स लग रहा है. Everyone think about it. सर यहाँ पे भी F depends on delta L. Delta L अगर ज्यादा होगा तो F ज्यादा होगा. यहाँ पे भी K depends, right? Yes or no? Think about it. Think about it. Yes or no? So can I say, okay, sir, so you mean to say that any rod can be compared as spring? Tell me, any rod, any elastic rod can be compared as spring? Tell me, yes or no? Can I do that? Yes or no? Can I do that step by step? Yes, makes sense now. हाँ या ना? I can do that, right? I can do that. Okay, chalo, very good. So if I'm comparing this rod with a spring, if I have to replace this, है ना? अब इसकी जगह मुझे एक spring डालना है. Think about it. Think about it. Instead of this, if I have to put a spring, है ना? Because it is easier to work with springs. ऐसा हो गया, है ना? जिसपे force लग रहा है F. Okay. So if I have to replace this with this, I have to find this K. So for this, right, this rod, what would be the value of K? Tell me, K का value क्या होगा? If you equate this term with this term, right, where delta L is X, what is K? K will be what? YA by L. हाँ या ना? Tell me, yes or no? Raise your hand, everyone, raise your hand. Yes or no? Step by step, step by step. Yes or no? सबको समझ में आ रहा है? सबको समझ में आ रहा है ना? Very good. So I can say, sir, if I'm having an elastic rod, I can replace it with a spring having spring constant K, where the value of spring constant K is YA by L, right? Any issues? सबको समझ में आया ये concept पहले? हाँ या ना? Okay, right. Now कोई बताएगा कि why I told you this? Because तुम लोग पूछ सको ना कि सर व्हाट इफ अगर जो पहले से elongated था उसका क्या होगा, पहले जो elongation था उसका क्या होगा? Doesn't matter, because whenever you talk about any additional force, right, है ना, any additional force, so the elongation due to any additional force has nothing to do with mg. समझ में आया? Yes or no? Because it will get cancelled. Yes or no? Tell me, है ना? समझ में आया सबको ये कि मैंने ये क्यों करवाया पहले, है कि नहीं? Right? Okay, very good. Any issues in this? Raise your hand. Any issues in this? Raise your hand. No? सबको समझ में आया ये? सबको समझ में आ रहा है? Basic. Prashasti, you got this, Prashasti? Shrikar? Suktika, Lohit, Kaushik, John, Vivek, Jaita, Vivek, समझ में आया विवेक सबको? Okay, right. So this is important, है ना? This is yes. Okay. Vivek, your voice is breaking, Vivek. Okay. I can't hear you actually. You just message now what you said. Okay. Now, why I gave this comparison, right? Why I gave this comparison? Because think about it. Suppose I'm having a problem like this. Think about it. Okay. And do you remember what was the first question that I asked before the class? That how many of you remember the series and parallel of resistance? Yes or no? Right? Okay. Okay. Chalo. Right. Now, think about it. So in last class, we solved a problem like this. Okay. In last class, I hope all of us remember that we solved a problem like this. This is first rod. Suppose this is your second rod. Right? And this is your third rod. Suppose. And they're connected. They're connected. Right? Look, they're connected, right? So iska मान लो Young's modulus of y1. This is y2. This is y3. This is a1, l1, a2, l2, a3, l3. Right? Yes or no? Step by step. Okay. Now, if I have to find delta L, if a force, external force, F is there, right? A pulling force is there, or a pushing force, doesn't matter. Restoring force, F is there. So, what is delta L? I have to find delta L, right? So, we have solved a similar problem in last class, right? John, remember, we have solved a similar problem in last class. Right? Guys, tell me. So how we solve this? How we solve this? How? Tell me. Think about it. Delta L was what? Delta L1 plus delta L2 plus delta L3. Yes or no? Very good throw. Okay. Now what is delta L1? What is delta L1? Vivek? Okay, sorry guys. What is delta L1? Basic formula. So F into L1, right? F into L1 by Y into A1. Yes or no? Correct. Delta L2 F into L2 by, so this is Y1, my bad, Y2 into A2. Yes or no? Yes or no? And delta L3 is F into L3 by Y3 into, tell me, A3. Right? Yes or no? Hi, Anna. Okay. Now, if I recall this concept, everyone recall this concept. Sir, YA by L can be treated as K1, K na? Tell me, right? Yes or no? Yes or no? Or this whole thing can be treated like this? Sir, it can be treated as this, that I'm having, this is first string, then second string, then this is third string, right? Yes or no? and the force F is used. The spring constant for this is K1, the spring constant this is for K2, this spring constant for this is K3. Can I treat it like this? Yes or no? Right? Okay, then what do you think? Delta L1 is what? F by K1, yes or no? हाँ या ना? Think about, देखो कैसे आ गया? F by Y1 by L1 is K1, right? Delta L2 is what? Delta L2 is what? F by K2. Very good. And what is delta L3? F by K3. Awesome. Very good. Very good. So what is delta L now? What is delta L now? What is delta L now? Sir, it is what? F bracket 1 by K1 plus 1 by K2 plus 1 by K3. Yes or no? Any issue in that? Tell me, any issue in that? Raise your hand. Very good, Suptika. Very good. सबको समझ में आया ना? सबको समझ में आएगी नहीं? Everyone is getting this? Everyone is getting the concept? Okay. Now, if I say, okay, sir, if instead of all the three, if I would had only one spring, suppose इस तीनों को हटा के एक spring मैंने मान लो लगा दिया, same equivalent concept, right? Equivalent concept है ना? And same force F लग रहा है, and इसका मान लो क्या है? K equivalent. Then in that case, what should be the value of delta L? So delta L should be F by K equivalent. Yes or no? Same concept, resistance wala type. Yes or no? Yes or no? Right? So if you equate these two, can I say, sir, F by K equivalent should be equal to what? F by 1 by K1 plus 1 by K2 plus 1 by K3. Yes or no? Right? So FF cut jayega, FF cancel. So what is 1 by K equivalent? 1 by K equivalent is 1 by K1 plus 1 by K2 plus 1 by K3. कुछ दिख रहा है? कुछ दिख रहा है ऐसा हमारा कहाँ आया था? हमने ऐसा K equivalent, right? ये तो K equivalent है, spring constant equivalent है, but ऐसा equivalent concept हमने कहाँ पढ़ा था? Parallel resistance, right? Yes or no? Parallel resistance है ना? Very good everyone, right? But यहाँ पे ये सीरीज में है कि पैरेलल में है? टेल मी, यहाँ पे स्प्रिंग्स जो हैं वो सीरीज में है कि पैरेलल में है? सीरीज में, right? So this is called a series combination of spring, right? So K equivalent of series combination of elastic rods या springs is given by this. Got it? सबको समझ में आया? Tell me, सबको समझ में आया? हाँ या ना? अनन्या, अनघा, अंकित, अथर्व, भावना, जॉयल, मौर्या, जॉन, नेहा, प्रीति, आज प्रबलिका एब्सेंट है, सुहास, right? Note it down, note this down, ठीक है? जैसे हम लोगों ने करंट में पढ़ा था, इन सीरीज करंट वाज कांस्टेंट, राइट? सो इन दिस फोर्स इज कांस्टेंट, राइट? है ना? फोर्स इज सेम. Any issues? Now think about it. If I'm having parallel, think about it. If I'm having parallel springs, in that case, what should be the value of K equivalent? Tell me. Without solving, common sense अगर लगाते हैं लोग, बहुत सारा इंट्यूशन लगाते हैं, वहां पे K equivalent वैल्यू क्या हो जाएगा? Tell me. As I said, it is just like simple sum. Very good Sampada, very good Snigdha. Correct, awesome, simple, right? Series formula, yes, K1 plus K2 plus K3 हो जाएगा. Yes or no? But हम लोग वो derive करेंगे, है ना? derive करेंगे वो. तो ये सबको समझ में आया? ये वाला. इस पे अगर सवाल रहेगा तो बन जाएगा. Can we solve the problem based on these concepts? Can we solve problem based on this concept? समझ में आ रहा है कि भाई what should be given, what we can do, right? Prashasti, tell me Prashasti, Abhilash, Mohit, Manogna, Nazneen is absent today, right? Okay. Now let us consider our series circuit, है ना? Series, not series. What?
Please scroll up and list.
Okay, right. Just note it down if you want to note this down. Okay. If it will be two springs, tell me if it will be two springs, right? A1, Y1, L1, A2, Y2, L2. So we can treat it as, tell me, two rods, है ना? Two rods. Sorry, we can treat it as just two springs which are in series, where K1 is A1, Y1 by L1, K2 is A2, Y2 by L2, right? So if you replace these two with one spring, which is K equivalent, then K equivalent will be what? Tell me, I hope all of you remember 1 by K equivalent. Yes or no? Tell me. 1 by K equivalent is equal to 1 by K1 plus 1 by K2. Right? So if you take LCM and reciprocal, so it will become what? K equivalent is equal to K1 into K2 by K1 plus K2. Same thing. Yes or no? Right? Yes or no? Okay. So this thing is clear. Everyone is clear with this concept. Raise your hand. Everyone is clear with this concept. Okay, so let us solve one basic problem. Okay. Okay. Just let me give you some different problem. Okay. Right. Now see this. See this. What is happening over here? Tell me. In this case, what is happening? We have three rods, right? We have three rods. Yes or no? Anna, how to solve this now? Tell me. So what can I say about this? Tell me, what can I say about this? So this and this are in series, no issues, Anna, right? No issues. But what about this? What about this? Anna, okay. So can you give it a try? Can you give it a try? Tell me. Can you give it a try? I'll give you 2 minutes. Just give it a try first. Just if you have to replace everything with only one spring, only one spring, Anna, only one spring, then what would be K equivalent for that spring? Right? That is what I'm asking. I'll give you 2 minutes. So it should be what? Think about it. It should be what? It should be K equivalent. Don't you think K equivalent should be what? First of all, these two should be replaced by one, right? So if you replace these two, then K equivalent 1 is equal to what? K1 into K2 by K1 plus K2. Yes or no? K equivalent 1. Right? है ना? Tell in दोनों series का correct. Then this and this will be in parallel. So K equivalent, net K equivalent is what? K equivalent 1 plus K3. Got it? Yes or no? Everyone got this? Yes or no? Tell me. Yes or no? Right? Okay. Now, obviously, this is a very good concept, right? I won't think that you guys will be asked these things, but let us try to solve some basic problem based on the first concept, है ना? Okay. Usually, our syllabus will be confined with only two springs. ठीक है? Not more than two springs. Okay. So this is a problem. I hope all of you understood this problem, right? Yes or no? So how it is used, मैं बता रहा हूँ, एसटीएम का मतलब बता रहा हूँ. Think about it. अभी हम लोगों ने पढ़ा नहीं है chapters. I'll just give you, because this chapter is used with all of the chapters. Okay, है ना? Now, how many of you remember the time period? How many of you remember the time period का formula in gravitation? याद है? 2 pi root L by G. How many of you remember this? Tell me. हाँ या ना? हाँ चलो, मैंने क्या बोला था? Time period is just 2 pi root L by G. Yes or no? You have to remember this. Okay. Now think about it. What if it is, this is a spring? Think about it. This is a spring. So at natural position, it would be resting. Yes or no? At equilibrium, it would be resting. Agree? What if you apply additional force? If you apply additional force F, what will happen? Tell me, what will happen? I hope all of you have played with this slingy or yo-yo or something like that, right? Yes or no? It will elongate. Obviously, it will elongate. What will happen after that? What will happen after that? क्या होता है? Rebound. Yes, it will go up. Yes or no? Yes or no? Then again it will come back. Again it will go up. Again it will come back. Yes or no? That is what happens. Tell me, yes or no? These are something that we observe from our normal life. This is something that we can visualize, right? So what kind of motion is called? Tell me, what kind of motion is this? 9th class में पढ़ा था ना हम लोगों ने basic oscillatory motion. याद है? याद है? Oscillatory motion class 7th में पढ़ा था, right? Yes or no? Period, right? So यहाँ पे क्योंकि वो straight line में हो रहा है, right? It is called as simple harmonic motion. This type of motion is called as simple harmonic motion or SHM. Got it? समझ में आया ये SHM होता क्या है? पूरा चैप्टर है इस पे बेस्ड, बट हम अभी बस बेसिक पढ़ रहे हैं, है ना? Okay, so the time taken by this mass, है ना, for one whole oscillation is called your time period. So spring का time period अभी नहीं निकाले, मैं formula बता दूंगा. Formula is T is equal to 2 pi root L by G. Sorry, not L by G. My bad. ठीक है, यहाँ पे L नहीं है ना, यहाँ पे L नहीं है कि नहीं? राइट, यहाँ पे L नहीं है, यहाँ पे K है और mass है. So obviously L by G should be replaced by M and K. Yes or no? L is replaced by, tell me, L should be replaced by what? Mass. Correct. L should be replaced by mass. ना G की जगह K आएगा, right? So this is mass. Wait, something happened. Yeah, mass by K. M by K. Got it? Right? M by K. है ना? So यहाँ पे देखो, याद है यहाँ पे G actually G effective होता था. Yes or no? If you remember the concept of gravitation, then it was G effective. If G will change, then time period will change. Yes or no? Right? Yes or no? So here also K is what? K equivalent. Yes or no? If K will change, then time period will change. Got it? Right? Now can I solve this problem? Tell me, can we solve this problem now, everyone, step by step? Right? Have we calculated K equivalent for this? What is K equivalent for this? What is K equivalent for this? Tell me, everyone, tell me. अरे अंकित भूल गया, अभी सीरीज में है तो उल्टा होता है. सीरीज के लिए पैरेलल जैसा, पैरेलल के लिए सीरीज जैसा. गॉट इट अंकित? सुक्तिका उल्टा, उसका उल्टा ना, उल्टा K1 into K2 by K1 plus K2, right? है ना? संपदा, it is 1 by K equivalent. ध्यान दो, 1 by K equivalent is equal to 1 by K1 plus 1 by K2. तो what is K equivalent? LCM हो गया यहाँ पे क्या हो गया? K1 plus K2 हो गया. But this is 1 by K equivalent ना, right? उल्टा करेंगे तो क्या होगा? ये हो जाएगा. Yes or no? Any issues in that? Got it? Everyone got this? Now, if I put this value here, right? If I put this value here, so what is the time period? The time period is given by 2 pi रूट m by k equivalent, ये वैल्यू पुट करूंगा मैं. So it is what? K1 into K2. Here it is K1 plus K2. Any issues in that? बताओ, any issue in that? Yes or no? This is direct formula which will be used, है ना? ओके सॉरी गाइज. हाँ, तो ये सबको समझ में आ रहा है कि नहीं आ रहा है? सबको समझ में आ रहा है ये? हाँ चलो. अगर ऐसा क्वेश्चन रहेगा वैल्यू पुट करके सॉल्व करने वाला तो हो जाएगा. ओके, सो लेट अस सी कितने लोगों को समझ में आया है. लेट अस सी, राइट, कितने लोगों को समझ में आया है ना? नाउ सपोज इफ आई आस्क यू अ प्रॉब्लम लाइक दिस, सपोज, ठीक है, कॉन्सेप्ट चेक. ओके, स्टेप बाय स्टेप. ध्रुव उसको अगेन, ध्रुव एसएचएम इज अ मोशन ना ध्रुव, राइट, है कि नहीं? तुम खुद सोचो ना, अगर तुम उसको थोड़ा सा पुश देके छोड़ दोगे क्या होगा वो? सोचो, स्प्रिंग को पुश देके छोड़ दोगे तो क्या होगा? टेल मी. ऊपर नीचे मूव करेगा ना, सो दैट मोशन इज एसएचएम. ओके ध्रुव, राइट? सो उसका मोशन ही, वो मोशन ही एसएचएम है कि नहीं? और यहाँ पे हम लोगों ने वही किया ना. ओके, so the concept is this. So this is a rod, okay, having area A, length L, and Y is your यंग मॉडुलस, और एक F फोर्स अप्लाई हो रहा है. ओके, राइट, दिस इज केस 1. ओके, now case 2 is this rod has been cut into half. Okay, has been cut into half, and now connected in parallel, like this. Okay, okay, so find K in case 1 and case 2. Right, tell me everyone, find K, net K, everyone, step by step. Can you do that? At least give it a try. I don't know when, since when it was paused. So I hope all of you understood this, है ना? So let us see some concept test. This first concept test. A 1 meter long wire of area cross section 1 centimeter square is stretched by 1.2 kg, है ना? Right? So all the information is given, right? Okay, start with information. So L is given, area is given, M is given, right? Delta L is given. How many times does it young modulus change, right? If its radius of y is doubled and length half, so y में change निकालना है. तो I can calculate initial y, yes or no? Y1 I can calculate, then y2 I can calculate, then you have to find y2 by y1, yes or no? Yes or no? This is what we have to do, right? Prashasti, are you getting this? Everyone? Renuka, Suptika, Anagha, Maurya, John, Manogna, Nazneen, you joined now. You're getting everything, Nazneen? Right? Prashasti, Preeti, Pravalika is not here. Okay. Try to calculate this. Guys, everyone. सबके अपने अपने नोटबुक में होना चाहिए. Try to calculate this. Right. So let us see the correct answer. So 9 students have selected A, 13. I guess all of you can see the wall, right? So the answer is D. Only 5 students have selected D. ठीक है? Only 5 students have selected D. तो देखो गलत कहाँ हुआ, है ना? Because it was basic formula putting and getting and then taking the ratio, right? Yes or no? Yes or no? Now, even if you don't do that, हम लोगों ने सवाल पूछा था. यहाँ पे देखो क्या लिखा है, how many times its young modulus change if radius of the y is doubled and length halved. Think about it. Why? Radius क्या हुआ? Double किया गया, है ना? Right? So a, sorry, y. अब तुम ये कुछ भी किया गया है. कल भी हम लोगों ने पूछा था सर y तो कांस्टेंट होता है ना सर, y डिपेंड्स ऑन मटेरियल सर. जब हम लोगों ने पढ़ा था स्ट्रेस बाय स्ट्रेन इज इक्वल टू y. याद आया कुछ? राइट? हाँ या ना? राइट? तो मैंने तुम लोग कंफ्यूज करने के लिए y1 y2 का रेशियो लेके कर दिया, राइट? अब तुम सब कंफ्यूज हो गए, सिर्फ 5 लोग से सब कंफ्यूज हो गए. यस और नो? थिंक अबाउट इट. कॉमन सेंस का सवाल था ये. Yes or no? What I said, what was you would think, and I wanted you to use your common sense. Now tell me, y1, if it is the same material, y1 is what? F, tell me, F L by A delta L. Y2 will be what? F L by A or A2 delta L2, A1 delta L1. This force will also change, no? But this is a constant, right? So this ratio will always be 1, na? Yes or no? But are you feeling silly? Tell me, are you feeling silly? हाथ चलो. Right? 5 लोग छोड़ के सब गलत किए है कि नहीं? Okay, चलो next concept test. Okay, next concept test. चलो. Okay, so this again I should get at least 30 answers. Guys, right? This one. A bulk modulus for incompressible solid is. Wait, I'll just change the poll. This is super easy. My bad. This is super easy, right? The bulk modulus for incompressible solid. Change हो ही नहीं सकता है. सोचो. Everyone. This is super easy theory. Incompressible का मतलब क्या हुआ? Tell me. Iron, titanium, right? Which cannot be compressed. Doesn't matter how much force you will apply, right? Delta will be 0. Yes. So कितना हो जाएगा? Think. Guys, only 13 answers. 14. इसमें तो टाइम नहीं लग चाहिए. इसमें तो इनी मिनी माइनी मो, right? Choose any. Guys, 18 answers. यार कितने आलसी हो यार, कितने आलसी हो. मतलब अगर अवार्ड मिलेगा ना लेजीनेस का तो बता रहे यू बंच विल बी द टॉप. I think there should be competition, laziness competition. Like एक क्लिक करने में इतना मेहनत लग रहा है, एक क्लिक करने में. 23, 24, 25, 26. अब 30 आज हो जाएगा तो A third. Have you answered? 27. 28. Two more. At least two more. At least two more. नहीं संपदा, मुझे पता नहीं चलता. Like I can know, but it's fine. 29 guys. कोई तो एक दबाओ. Okay, 30. Very good. चलो, let us see कि कितने लोगों ने सही किया है. So 10A, 17B. ठीक है सर, 0 अच्छा लगता है सर, बट आंसर इज एक्चुअली ए. एक्चुअली ए, राइट. भाई तुमसे पूछा क्या गया है? तुमसे बल्क मॉडुलस पूछा है. बल्क मॉडुलस फॉर्मूला क्या होता है? प्रेशर इज इक्वल टू बल्क मॉडुलस डेल्टा वी बाई वी. यस और नो? यस और नो? तुमसे प्रेशर नहीं पूछा गया ना, तुमसे डेल्टा वी पूछा गया है. सॉरी, तुमसे बल्क मॉडुलस पूछा गया है. तो बल्क मॉडुलस क्या होगा? पी बाई डेल्टा वी इंटू वी. यस और नो? यस और नो? सो अगर ये डेल्टा वी टेंस टू 0 है तो ये टेंस टू इंफिनिटी होगा ना भाई. यस और नो? टेल मी. बेसिक मैथ्स, बेसिक मैथ्स. यस और नो? राइट. 20 out of 30, only 33% are correct. Basic maths, basic maths. Got this? Everyone got this? Yes or no? Okay, right. Okay, चलो लास्ट टॉपिक, हमारा आज का लास्ट टॉपिक. सबको अच्छे से यहाँ पे ध्यान देगा. Okay, so I hope all of us know, right? All of us know that whenever we talk about the spring, है ना, spring, right, or any elastic body, right? Okay, work is done, yes or no? Work is done to extend them, yes or no? Tell me, yes or no? Work is done for the extension, yes or no? Change length. Agree everyone? Yes or no? Right? What is the formula of work done, guys? What is the formula of work done? Tell me. Work done का formula क्या होता है? Force into displacement, right? Yes or no? Everyone, step by step. Okay. Now, here displacement is your delta L. Yes or no? Displacement is delta L, na? Displacement is change in length, right? And I want to know, or this is your finite change, right? And I want to find infinitesimal change, right? Dx. Suppose it is dx, and this change is dx. So tell me, first of all, let's talk about spring. Let us talk about spring. So for spring, what is the value of spring force? Tell me, step by step. खुद बताओ, what is the value of spring force? Minus kx, yes or no? Right? Magnitude wise kx, है ना? So when you talk about work done, right? Work done का formula क्या होगा बताओ? Minus kx dot dx, yes or no? Yes or no? Right? Because here change is dx, right? Any issues on that? Tell me, any issues on that? Now think about it. If you talk about spring, everyone try to visualize this. If you extend spring in this direction, if you pull this in this direction, spring force will be in opposite direction, हाँ या ना? Right? Yes or no? So what is the angle between this displacement and force? What is the angle between displacement and force? 180 degree. सो डॉट प्रोडक्ट को करोगे तो क्या हो जाएगा, डॉट प्रोडक्ट को हटाओगे तो ऑलरेडी cos 180 आएगा माइनस kx dx cos 180 degree, and what is the value of cos 180 degree, -1, so it is just kx dx, right, है ना, for expansion, right, for expansion. Okay, right, for contraction also same thing will happen, right. Now this is what, this is dw, this is what dw na, right, which is kx dx. Now w is what, integration of this, makes sense, yes or no. So integration of dw is just w, and k is a constant, integration of x dx 0 से लेकर कहां तक, x तक मान लो, right. So what is the integration of x, guys, what is the integration of x, tell me what is the integration of x, x square by 2, very good, Dhruv, very good Jayita, very good everyone, very good Sutika. So it will be what k into x square by 2, yes or no. So it is what, half kx square. So this is and we know that magnitude wise potential energy, right, magnitude wise potential energy and work done are same, yes or no, yes or no. So if I ask you what's the potential energy stored in a spring when it extends to length x, so it is basically half kx square, yes or no, yes or no, ha ya na, tell me, right. Okay, so sir, it is easy to understand for spring, na. So let us talk about your rod. I hope all of you understood the spring wala. Suktika, John, Renuka, Atharv, Joel, everyone. John, are you noted this down? If you want to note this down, you can just note it down, right? But हम लोगों ने तो already कर रखा है ना, right? अगर याद नहीं था, because work energy हम लोगों ने already कर रखा है ना, जब potential energy drive कर रहे थे तो, है ना, right? Now, what do you think? Should there be any change? Should there be any change for your elastic rod? No, because the k will be same ना. The only thing that will change is k की जगह जो value था हम लोग का वो आएगा. Okay. Now think about it. For elastic rod, suppose I'm wait. Suppose I talk about elastic rod, है ना, ये elastic rod है. Okay. और इसका extension हो रहा है, right? Suppose this is extended by this length, है ना? This length is delta L. This is complete L, capital L. A is given, Y is given, right? So obviously we know that due to change in configuration, energy will be stored, and that energy will be potential energy, yes or no. So I want to find the potential energy due to this extension, right? Due to this extension. How to do that? Tell me. Same concept, na sir. This extension will be due to force F, yes or no? Yes or no? So what would be the formula of this force F? Tell me, what would be the formula of this force F? Tell me. I'll just write it as X, by the way. I'll just write it as X for our convenience. So this will be what? A Y X by L. Hayana. Hayana. Step by step. Yes or no? And same concept, right? For elastic rod. Same concept. Work done is equal to what? This force into displacement. Now displacement is what? For each point. Think about it, right? Displacement is variable now, because for each point, the displacement will be changing, yes or no. So let us consider this as dx, है ना? So it is F into dx, right? So dw, integration of dw is integration of a y x by L into dx. Now don't you think sir ये तो same हो गया sir, because this is actually k, this is actually k. जब हम लोगों ने इक्वेट किया था तो ये तो एक्चुअली k हो गया था ना. So exactly similar हो गया कि नहीं, लग रहा है? याद रखने का तरीका, exactly similar हो गया ना, right? Very good, Dhruv. Now is this constant? Can I take this outside? Can I take a y by l outside? So we are left with integration of x dx, है ना? और देखो ये यहाँ पे क्या है, इनिशियल लेंथ था मान लो l, फाइनल लेंथ हो गया मान लो क्या, या L1 है और ये L2 हो गया मान लो, राइट? L से लेकर L प्लस डेल्टा L मान लो, है ना? ये L से L2 इज L1 is L and L2 is L plus delta L. Got it? Right? So x का इंटीग्रेशन क्या होगा? What is the integration of x? I hope all of us know by now, है ना? ये हमें आता है already. Yes, ay x square. Okay, and this is what? So this is L to L plus delta L. Okay, now honestly speaking, right? यहाँ पे थोड़ा सा हम लोग अप्रोक्सीमेशन यूज करते हैं, डेल्टा एल का होल स्क्वायर कैंसिल हो जाता है, ठीक है, राइट? एक्स बाई टू, राइट? सो डायरेक्टली हम लोग लिख सकते हैं ए वाई डेल्टा एल बाई एल डेल्टा एल स्क्वायर, ओके, बाई टू. और I'll just do it, wait, I'll just do it. स्टेप बाय स्टेप मैं तुमको करके बता ही दे रहा हूँ. Just give me a minute. So a y by l. Now this will be what? L plus delta L, L plus delta L by 2. 2 बाहर मैंने निकाल लिया है ना. Whole square minus L square. Tell me what will be a y by 2L into a plus b whole square is a square plus b square plus 2ab minus L square. This will get cancelled, yes or no? Right? Now here delta L, think about it, delta L is actually very small, yes or no? अब बताओ इसके आगे क्या होगा? Don't you think so? Delta L is actually very small. Delta L will be very small, yes or no? Yes or no? Will delta L be small? हाँ या ना? Yes, it will be small, right? Okay. इसमें कुछ दिक्कत नहीं लग रहा है, इसमें कुछ दिक्कत नहीं लग रहा है. सर x जो है, थिंक अबाउट इट. सर आपने गलती किया यहाँ पे. टेल मी, मैंने गलती किया ना, बिकॉज व्हेन वी टॉक अबाउट x, x तो ये होता है ना. सॉरी गाइस, व्हेन आई टॉक अबाउट x, x तो एक्चुअली ये होता है ना, यहाँ से स्टार्ट होता है ना. इट इज 0 टू, यहाँ पे लिमिट जो होना चाहिए वो क्या होना चाहिए? 0 टू डेल्टा एल होना चाहिए, यस और नो? टेल मी. इट शुड बी 0 टू डेल्टा एल, नॉट l टू l प्लस डेल्टा एल. बिकॉज फोर्स जब लगता है तो वो तो एक्सटेंशन से लग रहा है ना. दिस x इज बेसिकली दिस एक्सटेंशन, यस और नो? टेल मी. तुमको कॉन्सेप्ट पता होना चाहिए भाई कि क्या हो रहा है. जब ये x था, व्हाट इज दिस x? x was this x the extension or the actual length? x was extension or actual length? Extension, right? है ना? तो एक्सटेंशन चेंज हो रहा है ना, तो 0 से डेल्टा एल तक. सो जो ये सब है ये क्या है? सर ये आपने गलत किया है ना? ये मैंने गलत किया है, yes or no? Think about it ना guys, yes or no? Because sir, are you integrating length or are you integrating change in length? Sir, I am integrating change in length, right? है ना? So this is just 0 to delta L. तो आराम से पुट करेंगे हम, डेल्टा एल स्क्वायर हो गया मेरा माइनस 0, राइट? टू बाहर है, yes or no? Got this? So it is just delta L square, delta L square. So सेम चीज आ गया ना, आ गया सेम चीज, हाफ into a y by l which is k into delta L square. सेम चीज आ गया, हाफ की x स्क्वायर, yes or no? हाँ या ना? स्टेप बाय स्टेप, हाँ या ना? just stay with me for 5 more minutes. ठीक है, for 5 more minutes. Okay, now let us try to rearrange some terms. Okay, so it is half, this is half by this is 2, this is 2 into, now think about it. Okay, What is the formula of stress? Stress is equal to what? Y into delta L by L. Yes or no? F by A की जगह पे F by A तो है, उसके अलावा Y into delta L by L. Okay, or F by A, right? Yes or no? And strain is equal to what? Delta L by L. Okay, so let us do something. Delta L squared by L squared into Y into A into L. Can I write like this? Can I write like this? Yes or no? L से मल्टीप्लाई डिवाइड किया ना मैंने, यहाँ पे L स्क्वायर हो गया, यहाँ पे L हो गया, हाँ या ना? So what is this delta L by L? Sir, is it strain square into Young modulus into volume? Area into length is volume. Yes or no? This is what? Potential energy. Okay, right? So can I say, sir, potential energy per unit volume is equal to half into Y into strain square? Yes or no? Okay, now potential energy per unit volume is what? Half into Y into strain into strain. Now what is Y into strain? Young modulus into strain को क्या बोलते हैं? Young modulus into strain is equal to what? Stress. Very good, right? Very good, Jaita. Very good. So can I say, so it is half into stress into strain? Right? It is potential energy per unit volume. And this is also called as energy density. Energy density. समझ में आया सबको? Yes or no? Everyone got this? Yes or no? Or it can be written as, what? Half into stress का whole square by y, है ना? Y से मल्टीप्लाई कर दो तो stress square by y हो जाएगा. Anyone have any doubt in this concept? Raise your hand. Anyone have any doubt in this concept? Anyone have any doubt in this concept? No? Yeah, right? Okay, right. So let us just see this few concept test, right? 5 minutes, then we will end the class. 5 minutes. Okay, so this is the concept test. Okay, generally when a metal is deformed by applying force to it, it stores energy, right? However, which of the following are incapable of storing any energy in this way? Simple. Perfectly elastic body, right? Perfectly inelastic material, material with elasticity properties midway of perfectly elastic and perfectly inelastic, all materials store energy. बहुत सिंपल एग्जांपल है, मैंने पढ़ाने से पहले ही तुमको आंसर दे दिया था. यस और नो? मैंने पढ़ाने से पहले ही एग्जांपल दे दिया था. पूछा क्या है? इनकैपेबल, इनकैपेबल, इनकैपेबल गाइस, इनकैपेबल, राइट? इलास्टिक एनर्जी की बात कर रही है. और सवाल देखो, ठीक है? जल्दी 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 जल्दी. Everyone, only 8 answers, 9 answers. 13 answers, step by step, guys. Only 13. Guys, think about it. अभी सिंपल सा नहीं यार, सोचो तो थोड़ा तो सोचो. Perfectly elastic, material with elastic, non-elastic, yeah, D. Okay, 15 answers. Students have given answer. I don't know what you guys are doing. Obviously, the answer is obvious. Perfectly inelastic. Yes or no? I think it was the very obvious question. यार यहाँ पे मैंने लिख रखा है यार, लिख रखा है यहाँ पे. Yes or no? लिख रखा है for elastic rod. Yes or no? Tell me. लिख रखा है कि नहीं? For elastic rod, right? In derivation only, I've written for elastic rods. Yes or no? Right? Inelastic होगा ही नहीं तो ये x होगा क्या? Extension होगा क्या? Delta x होगा क्या? If delta x is 0, how can the energy be stored? Yes or no? है कि नहीं? Common sense है ना? Right. Okay, guys. So, if you see your NCERT, apart from 1-2 topics, right, we have completed all the other topics. Okay, this chapter is 90% done. This chapter is 90% done. Okay, right? So next class will be your problem solving class. मैं class में करवाऊंगा problem solving class. ठीक है, मैं class में करवाऊंगा. Okay, all of you understood the concepts? Yes or no? Tell me, all of you understood the concepts? Right? सबको समझ में आया ना? Okay, right. So next class we will solve